Hello, students. Taking a look in section 2.3. Now, 2.3 does start with it's the other set operations that we haven't covered yet. So we've done complement, we've done subset, and those are great. The subset relationship is the if-then. The complement is the negation. So we're tying this back into section 2.1. But at the beginning of each section, you will also find in the textbook that you'll have the Common Core state standards, the CCSS. And it tells you, hey, this is a grade 1 topic. Students should be able to organize, represent, and interpret data with up to 3 categories. How many total are in there? How many are in each category? Okay. So we're going to make sure that you can do that at a level that is high enough that you should be able to answer any of the questions they may have. So in class, we talked about some of the key pieces, some of the key terms. We talked about the idea of intersection. We did an activity with colored pieces called attribute blocks, and you had to do things like a red and squares or yellow and triangles, and you would put pieces in the different regions. And where the sets overlapped, in this thing we called an intersection, we used the word and because the shape was yellow and a triangle, for example. Okay, so notice the definition. The intersection is the set of all elements common to both, just like an and statement with that we saw originally in 2.1. Both have to be true. That means X has to be an element of A and X has to be an element of B. Okay, so intersection is and. If there is nothing in between them and nothing in common, we tend to write a diagram or a picture where the two are completely separate because there's nothing between them. And that would mean the intersection is the empty set. Sometimes we call this disjoint. And you can kind of picture that. If they were joined, they'd have something in common. If they are disjoint, they do not have anything in common. So there's a nice little example with some sets that have numbers in it. The intersection is what is common to both. Sometimes there's nothing common to both. Sometimes there's many things. Let's continue on. All right. So here's a little word problem example. I'm not going to go through that. We'll do one at the end where we kind of work our way through it ourselves, but you're welcome to read through that one. I think it's a reasonable one to say. You have to understand that when we look at this picture, the B, let's say that's biology, it's easy to say how many students took biology and think it's 180, but we're really talking about the entire circle. So if we're talking about this entire circle for biology, oh, I need the filled in one. Where's the filled in one? Oh, here it is. So if I'm talking about the entire circle for biology, I want everything that's in there, everything. And that would be the 180 and the 20. So there are 200 biology students from this picture, not 180. Okay. So be cautious with this as you go forward. Set union. The union is the or statement. That means you have to be in at least one. Now remember, the or statement is the same as it was before. So we can think of it as one or the other or both. I prefer to think of it as meeting at least one of those conditions. Okay. Then they give a decent example where they say if A is this, find the intersection and the union with things like the empty set. Okay. And finally, now we have the union and the intersection. We come up with something called the set difference. The set difference of A and B is the complement of A relative to B. So I want you to pause for a second. I know that's a little complex. Here's the thought. Think of the set. Let me jump to the next page because I'll have an image of it. I think it's a little bit easier to see with the symbol. Okay, let's say we have B, and I'd like to, it looks like subtraction. And in a sense, it kind of is. We are taking something away in a sense. So that's why the symbol is pretty similar. So think of everything that's in B. That's every biology student, let's say. And then some of those biology students may be taking algebra, but I need to take everybody who's taking algebra out. So I may be removing some of the students that are in B. So we don't read this as minus. We read this as set difference. It would be minus if it was with numbers. These are sets, so it looks a little bit different. So basically, you want everything that's in B, and it cannot be in A. So if you're looking down here at the picture, If you shade everything that's in B with horizontal lines and everything in A with vertical lines, then B set difference A would be everything that's in B, but the stuff that's in A, pull it out. Get rid of it. Okay. So if you look at some basic questions here, A, set difference B, take a look. A is D, E, F. B has A, B, C, D, E, F. If you take everything that's in B and you remove it from A, you got nothing left. And the way we write nothing left in terms of elements would be the empty set. If you take set A and you take out everything that's in C, the C is an A, B, C. A is D, E, F. They don't have anything in common. So basically you taking out everything that's in C didn't change. So your answer would be A. Didn't change. Keep it the same. So that's the idea of set difference. Okay. And so they then ask, is it important to do groupings? How does groupings work? And honestly, if you think about the order of operations with parentheses, you might be wondering, I wonder if parentheses make a difference with sets. And so, yes, they do make a difference with sets. Here's an example showing that if I put the parentheses at the end, I get a single element. If I put them at the beginning, I get 4 elements. So we have to be careful. We may not always get exactly the same result. Turns out there is an order of operations for parentheses and for set operations. But for the level we're teaching at, that would be more of a high school or beyond concept. So for you, since we're going to focus on kindergarten through 8th grade at the maximum, we're not going to cover that. What we're going to say is if you're unsure, right, don't fight it. Just write it. Go write it out, find the values, and see if they are the same. All right, next they're going to do things like this. They're going to shade images and ask you to write what is shaded using set notation, using the set notation that they've covered. Okay, and honestly, there's a number of different ways you can write some of these. You'll notice even in their answers, they'll use the word or. So if you wanted to find individual pieces, for example, if you looked at this one right here and you said this region right here, hey, that's all of A. I just took out the stuff that's in B. And I would say, yeah, I like that. That covers that component right there. But I really need to describe all of the shaded regions. So then you would maybe say, okay, well, hold on, let me go over here. This shaded region over here is like I took B and took out everything that was in A. And I would say, absolutely, nailed it. And then your final answer would be, you could be in either one of these. So in order to solve the problem, you must be in at least one. At least one is an or statement. And that's the option that they show right here. Could you go a different direction? Yes. You could say, here's A and B, and you could say, well, I'll just take the union of those. And I'd be like, oh, that's cool. And then you would say, then I'm going to remove everything that's in the middle. And I'd be like, okay, that actually is the same piece. So for you, you might say it's the union and then set difference with the intersection. Yeah, that works. So there's more than one option. For questions like C, which are pretty common, here, if you look at it, you really have everything that's in A, and you just kind of removed everything that was in either B or C. So just kind of say that to yourself. Take everything that's in A and then pull out, because everything in A would also include these 3 regions. And then you're just going to say, well, pull out everything that's in B or C, and you've got yourself a solution. There you go. Done. Let's see here. Which one did they actually have that one listed here? Let's see here. A minus B. And, oh, there it is. Okay, so it's the middle one. Right. All right. So again, a lot of different ways you could write those. Don't think there's just one solution. Check your solution if you'd like to, but definitely more than one way to write those. Let's see here. Proving equality of sets using regions. So this would be if you're trying to prove two statements are the same, you look at which regions are covered by both. And if the regions match up exactly, then those two objects, those two sets would have exactly the same values. That's one way to show two sets are equal. Okay. The other way is to create sets like A and B and then show that it's true. The problem with that is it might only be true for your example. Maybe your example had some extra piece that you didn't notice in it, or it didn't include a broad enough category of additional objects. So Venn diagrams, we do use them as problem-solving tools. Every piece in a Venn diagram could be described. We did this in class. I said, what is this? And that would be a small hexagon that's not red. Those are the kind of things that we'd be looking at. So you'll be asked to identify things in words and also in set notation. Okay, so just realize when I say there's multiple correct answers, I really do mean it. If you wrote this down and you said region A, which is this chunk over here, and you said that region is everything that's an M, that's everybody taking math, who is not taking English. And you wrote it as M minus E, and another student wrote M intersect with E complement, right? So if you wrote that it was M and not E, those are actually exactly the same. So it's not that one is better or worse than the other. They are equal. So I would give full points for both of those. Okay. Let's see here. Let's do an actual Venn diagram problem. It says the following information was gathered. This is great. Maybe let's take a look here. How many students took biology, physics? Okay, so I'm not going to look at that answer. I'm going to click back here and I'm going to say, let's do this one together. Okay, so we have 3-circle Venn diagram because there are 3 classes, physics, biology, math. Let's see about this. This is kind of like that chicken problem that I gave in class. Okay, so here we go. So first thing I'm going to do is I'm going to give myself a little bit of a grid. So here's my grid. And here's my circles. So I need one circle here, need another circle here. As you can tell, they're not exactly circular, but as long as I have the intersecting regions, I think we're going to be okay. So then this up here would be physics, and this would be biology, and this would be mathematics. Okay. Now, it's easy. It's so easy to get kind of hung up on some of these. When it says 25 took physics, you could be thinking, 25 right here. But be really, really, really careful. If you put 25 right there, you're saying that these are 0. So what you're saying is that there's 25 that took physics, and then there's nobody took physics and biology, and nobody took physics and math is what you're saying. So you want to be really careful. I would encourage you not to put down those big pieces yet. This would be the total for everything in biology, the total for everything in math. Right? So let's hold on. Let's see what else we have here. Look for clues that can fill in an entire region. If you have a clue that says, hey, something about all 3, grab it. So here it says 5 took all 3 subjects. So I could put the 5 right in the middle because I know that I've got that clue. Okay. Now, the next clue up says 6 people took physics and biology. So pause for a moment. Physics and biology would be the intersection. So this eyeball region here is supposed to have 6 in it. I already have the number 5, and if there's 6 total, then the only thing that's missing is 1. So I would take this clue along with the clue I already have and be able to put one person that took physics and biology and not math, I should say. So if I look, there's 6 total in here, and that's perfect. Let's see here now, biology and mathematics. Let's do the same thing. So biology and mathematics, that's this eyeball region right here. There's supposed to be 8 total. I already have 5 people, so I would put a 3 in here. So I'm using the bottom clue and this new clue to check that off. Lastly, 10 people took physics and mathematics. Well, that's where physics and math match up. What do I know? I know there's 10. I already have 5, so I would have another 5 there because 5 plus 5 gives me 10. Okay. And now come back. Now come back and say 25 people took physics. Okay, well, I've already used up 5 and 5. That's 10 plus another one is 11, but 25 down here. So 25 take away 11 gives me 14. So there's 14 that took physics, but did not take biology and did not take math. Okay, we'll use the same thing for biology. Biology had 45. So 5 plus the 3 plus the 1, that's 9. All right, because 5 plus 3 is 8, plus 1 gives me 9. And so if that's 9, there's 45 that are total. So I need 45 minus the 9 that I already have, and that gives me 36. So that means there's 36 in that region out here. Lastly, 48 took math, clearly the most popular subject. So 5 and 5 gives me 10. 10 plus 3 is 13. So I have 48 total. I take away 13, and that gives me 35. Yep. All right. Not too shabby. Not too shabby, right? We got all the numbers except for one number. There's a number that might be floating out here, and I know there's 110 total. So if I were you, I would kind of cover something up, like take all of the math, right? And you know there's 48. So I would be like, okay, I have 48 right here. Then I would add the other 3 numbers, plus a 14, plus a 1, plus a 36. And then maybe I'd add those in a convenient way because I'm always a little sneaky. So 10 plus 30 is 40, plus another 6 and 4 is another 10. So that'd be 50. The 1 plus the 48 gives me 49. And so this gives me 99. Got it. Oh, well, there's supposed to be 110. So 110 are supposed to be in there. I used up 99. That gives us 11. So my final answer down there would be 11. Oops. Erase the whole thing accidentally. There we go. And that is how I could fill everything out. And of course, once I have everything filled all the way out, I could go down and turn the page and answer any question they have for me. And I'm not sure what the questions are here, but I think it's something like how many took biology, but not physics and not math. So how many took biology, but not physics and not math? That would be 36. And I can see it straight from my picture here. Okay. Let me get rid of all these pieces down at the bottom. That's kind of making it a little harder to read. Okay. B, let's see here. Number of students who took physics, biology, physics, math, or biology. So an or statement means at least one. So physics, math, or biology, I would add all the numbers up, and that would get me the 99. And how many students did not take any of those? Again, we already have that number sitting right outside, just be 11. So that's kind of a cool thing we can do with these regions is we can solve problems that would seem pretty complex otherwise. Let's see here. Cartesian products. Cartesian products produce ordered pairs. I think that's what you want to remember when you're doing Cartesian products. You have done Cartesian products before. You probably didn't realize it. Maybe you didn't realize it. But Cartesian products were how you would plot points. Like the point 2 comma 3 on a grid, you'd go over 2 and up 3, right? That was an ordered pair, which is known as a Cartesian product. And hopefully you remember that you couldn't just turn those around to get the same thing, because if you turned it around, then you'd be expected to go 3 forward and 2 up. So you would not get the same point necessarily if you just switch things around. So I just realized as you look at what they're doing here, if you look at it, they kind of have like almost an x-axis, which is the pants, and the y-axis, which is like your shirt. So when you see white comma blue, it means you're wearing white pants with a blue shirt. And that would be an ordered pair. Because if you switch that around and you say, what is blue white? Well, blue white means I'm wearing blue pants and a white shirt. All right. So that is Cartesian product. You can find a Cartesian product by just creating all of the ordered pairs. Pick the first element from the first set and the second from the second. So A cross B, you would take A with 1. A with 2, A with 3, and form those ordered pairs. Then move to the next element, B. B with 1, B with 2, B with 3. There they are. And finally, C with 1, C with 2, C with 3. So you can actually cross a set with itself, A cross A. You just pick your first one from the first, which is A, second one from the second, which is A. So A goes with A goes with B, A goes with C. Doop, doop, doop. B goes with A, B goes with B, B goes with C. Doop, doop, doop. So there we go for those. That about does it for the coverage. I'll come back with a few other questions. I've already done a couple questions out of here. I think I did a 5 and a 7, I think already, but I'll take a quick look and see if there's any others that look like they might throw you off. All right. So that's it for that section. That wraps up chapter 2 even. So boom. All right. Off you go.